Okay, let us start regarding classification of the underground cables. The cables for underground services may be classified in two ways according to the types of insulating material used in their manufacturers. The voltage for which they are manufactured, however, the latter method of classification is generally preferred, according to which the cables can be divided into following groups. This one is the cross-sectional view of underground cables. This part is impregnated paper. This part is your conductor, standard copper conductor here. This one is the layer of lead sheath. This one is the layer of impregnated papers, and this is the outer periphery of the cables that is serving. Then low tension cables, LT cables, carry the voltage up to 1000 volt. Next, high tension cable or ST cables carry voltage up to 11 kV volt. Next, super tension cables carry voltage from 22 kV to 33 kV. Next, extra high tension EST cables from 33 kV to 66 kV. Extra super voltage cables beyond 132 kV, that is known as extra super voltage cables. A cable may be one or more than one core depending upon the types of service for which it is intended. It may be of single core cable, it may be of two core cable, it may be of three core cable, it may be of four core cable. For a three-phase service, either three single core cables or three core cable can be used depending upon the operating voltage and load demand. Figure shows the constructional detail of a single core low tension cable. The cable has ordinary construction because the stresses developed in the cable for low voltages up to 6600 volt are generally small. It consists of one circular core of tinned stranded copper or aluminum insulated by layers of impregnated paper. The insulation is surrounded by a lead sheath which prevents the entry of moisture into the inner parts. In order to protect the lead sheath from the corrosion, an overall serving of compounded fibrous material, jute, etc. is provided. Single core cables are not usually armored in order to avoid excessive sheath losses. The single core cables are not usually armored in order to avoid excessive sheath losses. The principal advantage of single core cable are simple construction and availability of larger copper section. Cable for three-phase services. In practice, underground cables are generally required to deliver three-phase power. For the purpose, either three core cables or three single core cables may be used. For voltage up to 66 kV, three core cables, the LTG multi-core construction is preferred due to economic reasons. However, for voltages beyond 66 kV, three core cables become too large and unwieldy, and therefore single core cables are used. The following types of cables are generally used for three-phase services: belted cable up to 11 kV, screen cable up from 22 kV to 66 kV, pressure cables beyond 66 kV. First come to the belted cable. These cables are usually for voltages up to 11 kV, but in extraordinary cases they may be extended up to 22 kV. Figure below shows the constructional details of a three-core belted cable. The cables are insulated from each other by layers of impregnated paper. This one is the belted cables. This portion is, these are known as the thickness of insulation between the conductors. This is the paper belt, and thickness of insulation between the conductor and the sheath, this part. And this part is nothing but a lead sheath, help to protect the cables under mechanical injury or rough usage conditions. Another layer of impregnated paper tape called paper belt is wound round the grouped insulated cores. The gap between insulated core is filled with fibrous insulating material, jute, etc. So as to give circular cross section of the cable. The cores are generally stranded and may be of non-circular may be of non-circular shape to make better use of available space. The belt is covered with lead sheath to protect the cable against ingress of moisture and mechanical injury. The lead sheath is covered with one or more layers of armoring with outer serving not shown in this figure. The belted type cables construction is suitable only for low and medium voltages, as the electrostatic stresses developed in the cable for these voltages are more or less radial, that is across the insulation. Second one is screen cable. These cables are meant for use of up to 33 kV, but in particular cases their use may be extended to operating voltages up to 66 kV. The two principal types of screen cables are H-type cables and SL-type cables. First one is H-type cables. This type of cable was first designed by H. Hosteller and then the name. Hence the name. Figure shows the construction detail of a typical 3-core H-type cables. Each core is insulated by layers of impregnated paper. The insulation on each core is covered with metallic screen, which usually consists of a perforated aluminum foil. The cores are laid in such a way that metallic screens, these are the cross-sectional view of the belted cables. This is serving, this layer is armoring, this portion is beading, this portion is lead sheath, this one is conducting belt, this is paper insulation, and this is the metallic screen. Make contact with one another. An additional conducting belt, copper woven fabric tape, is wrapped around the 3 cores. The cable has no insulating belt, but lead sheath, beading, armoring and serving follow as usual. It is easy to see that each core screen is in electrical contact with the conducting belt and the lead sheath. As all the 4 screens, 3 core screens and 1 conducting belt and the lead sheath are at earth potential, therefore the electrical stresses are purely radial and consequently dielectric losses are reduced. Two principal advantages are claimed for H-type cables. Firstly, the perforation in the metallic screens assists the complete impregnation of the cable with the compound, and thus the possibility of air pockets or voids in the dielectric is eliminated. The voids, if present, tend to reduce the breakdown strength of the cable and may cause a considerable damage to the paper insulations. Secondly, the metallic screens increase the heat dissipation power of the cable. It is SL-type cable. It is consist of this type. This one is serving, second portion armoring, third layer cotton tape, fourth layer conductor, and this one is lead covering. So figure shows the constructional detail of a 3-core SL-type separate lead type cable. It is basically S-type cable, but the screen around each core insulation is covered by its own lead sheath. There is no overall lead sheath, but only armoring and servings are provided. The SL-type cables have two main advantages over S-type cables. Firstly, the separate sheaths minimize the possibility of core-to-core breakdowns. Secondly, bending of cable become easy due to the elimination of overall lead sheath. However, the advantages is that the 3 lead sheath of SL cable are much thinner than the single sheath of S cable and therefore called for greater care in manufacture. Next one is pressure cable. For voltages beyond 66 kV, solid type cables are unreliable because there is a danger of breakdown of insulation due to presence of voids. When the operating voltages are greater than 66 kV, the pressure cables are used. In such cables, voids are eliminated by increasing the pressure of compound, and for this reason they are called pressure cables. Two types of pressure cables, that is oil filled cables, gas pressure cables, are commonly used. Next, oil filled cables. In such type of cables,